Billions of years ago, the red planet was far more blue. According to evidence still found on the surface, abundant water flowed across Mars and forming pools, lakes, and deep oceans. The question, then, is where did all that water go? The answer: nowhere. According to new research from Caltech and JPL, a significant portion of Mars' water, between 30 and 99%, is trapped within minerals in the planet's crust. The research challenges the current theory that the red planet's water escaped into space. The Caltech JPL team found that around 4 billion years ago, Mars was home to enough water to have covered the whole planet in an ocean about 100 meters deep, a volume roughly equivalent to half of Earth's Atlantic Ocean. But, by a billion years later, the planet was as dry as it is today. Previously, scientists seeking to explain what happened to the flowing water on Mars had suggested that it escaped into space, victim of Mars' low gravity. Though some water did indeed leave Mars this way, it now appears that such an escape cannot account for most of the water loss. Atmospheric escape doesn't fully explain the data that we have for how much water actually once existed on Mars, says Caltech PhD candidate Eva Skeller, MS-20, lead author of a paper on the research that was published by the journal Science on March 16 and presented the same day at the Lunar N. Scheller's co-authors are Bethany Ehlmann, professor of planetary science and associate director for the Keck Institute for Space Studies, Yuk Young, professor of planetary science and JPL senior research scientist, Caltech graduate student Danica Adams, and Renyu Hu, JPL research scientist. Caltech manages JPL for NASA. The team studied the quantity of water on Mars over time in all its forms, vapor, liquid, and ice, and the chemical composition of the planet's current atmosphere and crust through the analysis of meteorites as well as using data provided by Mars rovers and orbiters, looking in particular at the raw water is made up of hydrogen and oxygen, H2O. Not all hydrogen atoms are created equal, however. There are two stable isotopes of hydrogen. The vast majority of hydrogen atoms have just one proton within the atomic nucleus, while a tiny fraction, about 0.02%, exist as deuterium, or so-called heavy hydrogen, which has a proton and a neutron in the nucleus. The lighter weight hydrogen, also known as protium, has an easier time escaping the planet's gravity into space than its heavier counterpart. Because of this, the escape of a planet's water via the upper atmosphere would leave a telltale signature on the ratio of deuterium to hydrogen in the planet's atmosphere. There would be an outsized portion of deuterium left behind. However, the loss of water solely through the atmosphere cannot explain both the observed deuterium to hydrogen signal in the Martian atmosphere and large amounts of water in the past. Please support our channel to grow by pressing subscribe button as well as the bell icon for daily updates. Thank you.